Hello AGD coders, and welcome back to another video, and we are going to be continuing our look at lookup tables and how they can enhance your games. And today we're going to go a step further than what we did in the previous video, and I'm going to show you how you can create a bullet which can move in up to 16 different directions. So I'm going to create a bullet spawner like a sort of sentry gun like this. And as you can see, it will fire randomly in anything up to 16 different directions. And this is controlled by using a lookup table to determine a particular set of coordinates that we want to add to the X and Y. So so that's basically that. It's very customizable. You can do lots of different effects with it, and we will have a look at those later. But first of all, let's look at the basic concept and the lookup tables itself, the actual table. So I'll drag this over, and here you can see, if you imagine, this is the center, and we're looking at a sort of clock face with 16 numbers on it from 0 to 15. And this is going to control our direction. So we've got here, obviously with AGD, X is the vertical direction, so something we all have to get used to. But what you can see here is that we can move up or we can move left and right, and here for each of these numbers corresponds to a different amount that we want to add, and that goes around the whole clock. So 0 means subtract 2 from X, 1 means subtract 2 from X and add 1 to Y, and I've created a table here which shows you basically what you need to add to X and Y to get that direction. So 0, 1, 2, 3, 4, all the way around the whole thing, as you can see. So 2 would be here, and that goes all the way down there. So 2 would be minus 2 on X and add 2 on Y, and so on. So that's basically the pattern, and that will mean that whatever number we give to AGD, it will add the corresponding numbers in X and Y to the sprite position, and that will allow us to give the sprite anything up to 16 different directions here. Now obviously what you can see here is minus numbers, and obviously that's not going to work with AGD, but what I've done is I've converted it here into full integers, which we can have here. So 254 would be the equivalent of minus 2, 255 is minus 1, and there you can see the same code that we have for the Y direction. Now what you might also notice here is that if you look here at X, it actually corresponds to the list for Y, and that should make sense really, because if you look at the clock here, 4 is there and it goes back there, if you like, to 0 by basically horizontal to vertical conversion means moving it across by 3, or indeed adding 12 depending on your perspective. So basically if we want to know the value of Y, you can see that the value of X corresponds here to Y would be plus 4. Plus 4 on X would give us the value of Y. So we don't actually need a table for X and a table for Y. All we need to do is get a value for X and then add 4 into the lookup table, and that will give us the value for Y. So we only need this first set of numbers here from 254, 254, 255 and so on, all the way down. So there are 16 numbers in total, and that will be enough of a lookup table for us to actually control both coordinates quite easily. So yeah, basically now we've got that idea of a lookup table. Obviously what we'll do is we'll transfer it over to AGD, and we'll be able to look at how that can be accessed through the code that we showed in the previous video. So let's open hexit2dat that we used as in the previous video, and as you can see here, I've made a list of numbers like a data statement which correspond exactly to the ones that we've just looked at. So starting with 254, 254 all the way down there, and that's the total 16 numbers here which we can transfer into our AGD code. So let's do that. What we'll do is we'll save it off here. Let's just call it we'll call it clock out. That will do, that's easy to remember. And so we'll save that off, and let's move that out of the way and get over to AGD and load that into our object. So here's our object, and as you can see here, 37514 currently is where it starts. So we just load our binary data, and the one that we've just created, which is called clock out, we'll open that and we'll put it in at 37514. Just like that. As I said, if you want this bin out program, you can download it from the previous video, and as you can see here, it's quite a nice pattern, and that is our shape that we need, all the numbers that we need for our lookup table. Alright, so let's now look at how we actually create the actual sprite and the spawning. So if we go here, as you can see, that is a type 2 sprite, and I've created that in the sprite editor. And here, as you can see, there is a bullet, and there's our sprite there. And I've got two frames, one here, and the second frame is one where it's empty, as though it's actually the missile has fired, and the next one gets sort of loaded up, so to speak. That's the kind of effect I was going for there. Obviously fairly limited with the 16 by 16 image, but it does work pretty well. Alright, so let's take a look at the spawning section. So if you've watched my previous video about bullets and sprite bullet tips, that would be a good help here, because I'm using a similar technique. So I'm using PMB as a timer here, and PMB is going to count down from whichever number I tell it down to 0. Obviously I need to set that in the initialize sprite section, and you should go back and do that to set the default level that you want. Now let's look what happens when PMB does equal 0. First of all, if 5 is greater than D, D is a bullet counter, so we're going to limit our bullets to 5. Again, that was in our previous video about sprite bullets. We then get a random number, make a beep, and then we spawn sprite type 1. And we set the PMA of sprite type 1 to be a random number here, as you can see, between 0 and 15. We add 1 to the bullet count, and we then set parent to 20, so it starts counting down, and when parent reaches 10, we create the image which shows the bullet has been restored. So overall, basically that fires a bullet at a random direction from 0 to 15, and let's take a look at that bullet now and see how we control it. So what we're doing here, of course, is we're going to read the object and look up the table from 0 to 15 to find out what we should add to X and what we should add to Y. So here is object 0. We set opt. PMA is going to store our bullet direction here, so we'll set opt to PMA. So as you saw, we set PMA, the spawning sprite set PMA to a particular number which was random. We then look it up in the lookup table using the ASM, and we add that number to the X coordinate. We then add 4 to opt, which is obviously how we look up our Y coordinate in the same lookup table. And obviously what we need to do there is check to make sure that opt doesn't go over 15. So for example, if it's 13, we need to basically, it would become 18, then we need to set it back to 2 so that it's a full circle, so to speak, because the table is basically circular. We're going around in a clock. So yeah, we do the same thing, add the figure to rand, and then finally what we do at the end here is we set rand to 0, and this is we're using rand as a temporary variable, nothing to do with the previous bit of code, but this is how we do a check on a number of different possible things. We want to check if y is less than 4, if x is less than 4, if y is greater than 170, if x is greater than 140. So all of these checks will set the variable rand to 1, and that's the equivalent of using OR, because obviously you can't use OR in AGD, but if you do something like this, you can trigger one flag for a number of different conditions, check it at the end, and if that happens, subtract 1 to the number of bullets and remove. So basically if we look back here, yeah, that's basically what's happening here. It's generating a number from 0 to 15. It's looking that number up in the lookup table. It's then working out what it needs to add to either x or y. Then it's adding that to x or y. And finally it's checking to see if the bullet has gone off the screen and if it's allowed to spawn another bullet. And that's basically the way that that works. Now obviously there's quite a lot of different things we can do here. One of them, first of all, is if we want to, we can add rand to y and to x here. Sorry, to x and to y, obviously. And this will basically double the speed of our bullet. So there you go, our bullets are now firing twice as fast. They're basically moving twice as fast because we're adding to the sprite position twice rather than once. So that's how you can control the speed. You could also, for example here, I could change maybe just x to once and y to twice, and it'll have a different effect. Some of them bullets will be slow and some of the bullets will be faster like that. So again, just something to play about with if you want to. So yeah, that's how you can control that. Now we can also control other things. We can control the rate of fire. That's pretty easy to control as well. So let me just put this back first of all, and we'll go back to the sprite, to the spawner here, and we'll make some changes. So here I'll set the param B here to be 10, and I'll set here to be 5, so that's going to be twice as many now. And if we go back, we'll see, there you go, so now it's firing out quite quickly, but the limit is 5, so the maximum number of bullets on the screen will always be 5, and that still gives us plenty of other sprites to play with, so shouldn't have any real problems there. Okay, so what else can we do? Well, one of the things that we could do is, rather than it be random, we could change it here. So let's take a look here. What we'll do is we'll get rid of this random number here. And what we want to do now is basically cycle through the whole clock from 0 to 15 and fire out bullets for each sort of clock number, and that will basically fire out a series of bullets in the sort of circular motion. So what we'll do is we'll add one to dir, because we know that we're going to store our number in dir, and we'll check if it's greater than 15, and if it is, it'll go back to 0. And then we'll just set the random number here, the one that we were using before, to be dir. And it's important that we use rand here rather than dir, because obviously dir is a local variable, and when we spawn a new sprite, obviously it will have its own dir. So we'll set the PMA here to be rand, and let's see what happens. And as you can see, now it is firing out bullets in a circle, just like that. It's a little bit slow though, so let's try and see if we can change that and have it fire things out a little more quickly. Let's really crank it up a little bit here. I'll change the param B here right down to something like 6, change this one to 3, and there you go. Now we're getting a pretty cool effect. So yeah, that's the kind of hazard that would be pretty tricky for a player to negotiate, and the good thing about that, of course, is that it's more predictable than random. There's nothing more annoying in a game than a sort of randomly fired projectile that's completely unfair and just kills you. It's much better if the player has a chance to actually predict and use his skill to avoid it. Okay, so let's look at some other things that we can do here. What I'm going to do now is show you how we can add a second bullet. So I'm going to add 8 to our random number. Now remember, the clock is 16, so if we add 8, it will be exactly opposite to the first bullet. So we'll again do the same check. If rand is greater than 15, we'll subtract 16 to rand. We'll then spawn the bullet, the new one. This is a second bullet, and we will then set the PMA of the new bullet to be rand. And obviously now we're making 2 bullets, we're going to add 2 to D. And if we take a look at this, we'll also just slow this down a little bit, because more bullets, it's going to be a little bit crazy if we don't get it under control. So yeah, as I said, that adding 8, that's going to basically create 2 bullets that move in opposite directions, and we just need to check there to make sure that we go over the limit. Let's take a look, and as you can see, it's getting pretty cool, isn't it? That would be very tricky to avoid, I think, but you know, as I said, it's totally flexible and you can do whatever you like with it, really, and it's quite a bit of fun. Alright, so yeah, it's getting pretty complex and pretty interesting. Let's see if there's anything else we can do. Well, one of the really cool things we can do is we can actually have an influence on the bullet itself. So rather than just have it moving straight, we can actually make it move in a curve, because we've got this lookup table. We can pretty much control the direction. So as you can see there, I've got an animation timer limiter, so it's going every 3rd cycle, because if I curve it too much, it'll just go in a circle. At the bottom of here then, I'm checking if C is 0, adding 1 to param A, same check again, if param A is greater than 15, let param A 0, end if. So now we're cycling through the clock with our bullet. So as the bullet moves around, as you can see here, PMA is going to be increasing. So as the bullet moves along, it's going to be turning as it moves, and as you can see here, this is a pretty nice effect, and there you go. So these are the kind of effects that you really probably don't see in many games in AGD, and as you can see with the lookup table, they're really pretty straightforward. Yeah, and we can go even further than that. In fact, what we could look at now is perhaps we'll have a little play about. Perhaps we'll add a little bit of animation, and maybe even add a trail effect, and then we'll really be cooking with gas. So let's have a look on here. I'll just put a little bit of animation in here, create a couple of frames, and just play about with that. Again, I'm just kind of playing about here. You can do exactly what you want as well. That's really part of the fun, just to kind of experiment, to see what works and see what kind of effects you can get. So yeah, that's not bad, but I think I'll just cut those out there. And okay, that looks okay. Let's see what happens. Yeah, so that's kind of pretty, isn't it? Not too bad. And we can also look at maybe adding a trail. So let's try that here. You have to be careful with using trail, because it can use up quite a lot of processor power. We'll try adding a trail with a single effect, and well, it's okay, but the trail isn't really doing what we want it to. There's not enough of it there, is there, basically? I mean, it looks okay, but I think we can probably do better than that if we increase the trail. So let's try and play about with that a little bit more. Perhaps if we oops, sorry about that. Let me just jump back in a second. Let's go down here, and we'll make it a little bit slower so that we don't overdo things on the processor. And then we'll increase this. We'll take this away here, and we'll add a bit more trail on here, and this should look pretty good, I think. So let's see. Yeah, there you go. That's pretty cool, isn't it? So yeah, look like little missiles firing out, and so not bad at all, really. Pretty good. Okay, so what else could we do with this? Well, there's a couple of other options. We could, for example, create let's just see what we do here. Let's try and change this a little bit. I'll just reduce that down. Yeah, that's also okay. Again, I'm just messing about here, really. I haven't really edited this part of the video, just improv, really. But that's also part of the fun, isn't it? So let's see what we can do next. Let's see if we can push it a little bit more. Perhaps we can let's see, perhaps we'll just reduce it reduce the number of sprites, and yeah, we'll take one out like that, and obviously we need to change the timer to make it a lot faster. So let's really push the speed here, and okay, that's alright, but yes, I've forgotten something. Maybe you noticed, because we're only generating one bullet now. We need to change this bullet count so that it doesn't go over its limit. And yep, okay, and there you go. So now we're really spitting out like a spurt of bullets like that. Again, quite a nice effect, I'm sure you agree. And really, I suppose the main thing I'm wanting to show you here is the fact that with just a few small changes, when you're using a lookup table that allows you to control 16 directions, then it only really takes a very few changes in the code to create some really nice effects that you won't see in too many games, although obviously perhaps now with this video there might be a few more, and that would be good to see. Okay, so to finish up, let's just look at a couple more effects that you might like to try. One of the things we could do here is, rather than use the whole clock face, we could just use part of the clock face. So for example, here, as you can see, I've set it to be 15, between 15 and 8, so basically it's going to be the left side of the clock face. And I've changed the PMA here so that it's subtracting to PMA and then checking and going back to 15, and that means it's going to be moving in a clockwise direction rather than the anti-clockwise direction that you saw in the previous video. And what we'll do here is move it over across to there, and as you can see, we've now got a sort of sprite emitter which is on the right hand side, and it's firing out bullets only to the left. So again, that could be a sort of sentry point or a guard or something here. It's also possible to move the sprite that's firing. That would be possible, although you're a little bit limited with the number of local variables, but could be doable. And of course, the other possibility, let's just make some changes here. I'm going to switch this back to its full circle. And I think what we'll do now is I'll just show you one more thing you could try. Perhaps you've thought of it yourself. Is let's put one here, and we can add another one over here, and we can have more than one. And because we're limiting the sprite bullets, then these two will share bullets between them. And as you can see, that's what's happening there. Sometimes it's firing out on that one, and then occasionally the other one sort of kicks in. And again, so you can play about with this very much. You can certainly create a lot of fun effects. You could perhaps even play about with colors, maybe experiment with explosions as well. Perhaps you could make the stars explode at certain points on the screen. That might be also fun. There's really a whole new range of things I think that this kind of thing can open up. And as you can see, it's very, very low on the memory, and not too difficult to achieve. So I hope to see that some of you might like to try some of these things in your games and add a bit more variety, because you know, for any player, variety is always the spice of life, just as it is in most things in life. Okay, so anyway, on that note, I think I'll let you go. Thanks again for watching. I hope that you enjoyed it. As always, keep enjoying the spectrum, and happy coding. Bye bye.